Hi guys, so today we will be discussing about suture materials, right? Okay, so as you can see in the screen, there are absorbable sutures as well as non-absorbable sutures, right? So we will discuss about each of them. We will look at their materials, tensile strength, absorption rate, tissue reaction, differences, their uses, etc. Okay, so we will take this in a separate video. Like in one video I will discuss about absorbable, and another I will discuss about non-absorbable sutures, right? So starting on with your absorbable suture materials, right? So here I am discussing about your absorbable sutures. Okay, so I am making a table. Okay, this is your suture. Here I will write the types, and next I will write about your raw materials, right? Raw materials. Here I will write your tensile strength, followed by your absorption rate, okay, and tissue reaction. Alright, so if we start with your catgut, okay, so catgut types are your plain catgut and chromic catgut. So first we will talk about plain catgut. Raw material, actually it is derived from, it is the collagen, okay, that is derived from healthy sheep or cattle, okay. Your now the tensile strength retention, okay, retention of tensile strength. So actually the tensile strength is lost within 7 to 10 days, okay. It is now this type of catgut is usually not recommended, all right. So 7 to 10 days tensile strength lasts, okay. Now absorption rate is actually okay, absorption rate is it is degraded within 7 to 10 days, all right. And the mechanism is by phagocytosis and enzymatic degradation, very important, okay. Phagocytosis and enzymatic degradation. If we talk about tissue reaction, this particular catgut has high tissue reaction, okay. So this is about your plain catgut. Now if we talk about your chromic catgut, now the raw material of your chromic catgut is the collagen that is derived from healthy sheep of cattle, tanned with chromium salts to improve the handling and to resist degradation in tissue, okay. In simple terms we can say same thing, collagen of sheep or cattle, but here we will add plus your chromium salts, okay. Again the tensile strength is lost within 21 to 28 days, okay. The absorption rate is actually 90 days. Within 90 days it is fully absorbed. Mechanism is phagocytosis and enzymatic process, and it has moderate tissue reaction. Each and every word is important, right? So let's revise the catgut. So there are two types of catgut: plain, chromic. Now plain and chromic, both raw material is the collagen that is derived from sheep or cattle. In chromic there is an extra, in addition chromium is added, okay. Tensile strength, catgut has 7 to 10 days. and this one plain, and a chromic one has 21 to 28 days. If I talk about absorption rate, for plain it is 7 to 10 days. Mechanism is phagocytosis and enzymatic degradation, whereas in Chromic Cad Guard it is 90 days. Same mechanism, phagocytosis and enzymatic process. Tissue reaction, plain Cad Guard high, Chromic Cad Guard moderate. Now let's move forward. Okay, so now it will be one second. Polyglactin. Okay, now polyglactin, actually the type is braided multifilament. Okay, simply remember multifilament, because there are multifilament, then monofilament. All right, so we will discuss this. Okay, so multifilament type. So just for completion's sake, I am mentioning that the raw material is your lactite and glycolite in a ratio of 90:10. Okay, and now it approximately 60%. It is this tensile strength. 60% remains for 2 weeks. Okay, and rest 30% will remain by 3 weeks. If I talk about absorption rate, it is almost 60 to 90 days, and the process involved in absorption is your hydrolysis and with mild tissue reaction. Okay, mild tissue reaction. So this is about your multifilament polyglactin. If we talk about your monofilament, same polymer, copolymer of glycolic acid and trimethylene carbonate this time. Okay, a multifilament was a copolymer of lactide and glycolite, and monofilament is your copolymer of glycolic acid and trimethylene carbonate. Okay, and here 70% tensile strength remains by 2 weeks, and 58% remains by 3 weeks. All right, now regarding your absorption rate, so it remains by 8 to 9 weeks. All right, and it is by hydrolysis, but for complete absorption it will take 180 days. Okay, and tissue reaction is mild here. All right, so if you just revise up the things, that your multifilament polyglactin, it takes 60 to 90 days for absorption, and the mode is a hydrolysis. On the other hand, a monofilament takes 180 days for complete absorption, same hydrolysis procedure. So we saw that the process involved in absorption of Cad Guard is your phagocytosis and enzymatic degradation, whereas polyglactin, the process involved for absorption is your hydrolysis. All right, let's move on. Now it is polyglycolic acid. Polyglycolic acid. Now here this it is a polymer of polyglycolic acid. Okay, and it is absorbed by a this one hydrolysis procedure only. So approximately if I talk about the tensile strength, approximately 40% by 1 week. Okay, 40% will remain by 1 week, and 20% remains by 3 week. Okay, now let's talk about the absorption rate. So by 2 to 4 weeks, it will be absorbed by 2 to 4 weeks, but for complete absorption it needs 60 to 90 days for complete absorption. Okay, so by 2 to 4 weeks we will get the absorption will be good, but for complete absorption it will take 60 to 90 days. And yes, what is the mechanism? Same, hydrolysis. Okay, hydrolysis. So next let's move with what we'll discuss next. Okay, PDS. Okay, very important, polydioxanone. Okay, so it takes the tensile strength remain is here 40% by 1 week, 20% by 3 week. Okay, but the important thing is your absorption rate. Okay, so it by 90 days absorption is almost complete, but for full completion I will go for 180 days, right? So it takes 180 days for full absorption. Again, mechanism is your hydrolysis. So if you have to choose one answer, you will go with 180 days. Okay, but minimal is your 90 days. All right, same with every this one sutures I mentioned. This is your maximum value. Okay, so talking about polydioxanone, it takes 180 days for complete absorption by hydrolysis procedure. Okay, now let's move on to the this one, polyglycaprone. Okay, polyglycaprone. Now it is a copolymer of glycolite and caprolactone. Glycolite and caprolactone. Caprolactone. All right. And tensile strength is maximum. It remains up to 21 days, and for absorption it maximum takes 90 to 120 days with mild tissue reaction. Okay, so this is your absorption rate, 90 to 120 days, right? This is the number of days it takes to absorb, to be absorbed. So let's see all the sutures again. First so these are your absorbable sutures. Okay, first we took plain catgut. So the absorption rate is almost 7 to 10 days for the plain catgut. Mechanism is your phagocytosis and enzymatic process, right? For chromic catgut it's 90 days, right? Same mechanism. For polyglactin, the absorption is almost 90 days by hydrolysis. For the multifilament type, for monofilament it's almost 180 days by hydrolysis. Polyglycolic acid maximum 60 to 90 days absorption time by hydrolysis. For PDS it is 180 days by hydrolysis. For polyglycaprone it's 90 to 120 days. Okay, so this is about your absorbable suture materials. Next we will discuss about non-absorbable suture materials. Okay.